Okay, we have another integral. This one's from the UNSW Integration Bee 2024, round 2, problem 9. You have the integral of the infinitely nested square root of x plus square root of x plus square root of x dx. Okay, it seems like pretty much every time we come across one of these infinitely nested expressions, the way to go is to set this equal to another variable and try to reduce it into something we can work with. So what I want to do is call this whole thing y. And then in order to get some simplification, let's just square it. And what's going to happen is this first x is going to pop out. We're going to have x plus, and then we're still going to have all this other stuff. But the thing to notice here is because this is infinitely nested, this piece right here, it's actually the same thing as the whole integral. It's actually the same thing as y. So we can just actually call this y. And so what I can do is rewrite this. We'll write it as y squared equal to x plus y. And now what we have is we've got a quadratic in y if we just rearrange this. So coming over here, I'll subtract the x plus y on both sides. We're going to end up with y squared minus y minus x equal to 0. But from here, in order to solve for y, I can just use the quadratic formula on this. We'll kind of look at like our b value as minus 1. And this minus x will be like our c value. So going ahead with this, we're going to have y equal to minus b, so that's just going to give me a 1 here, plus or minus square root of b squared, that's going to give me a 1, minus 4ac, so a is 1, and our c is just going to be this minus x value. And this is going to be all over 2a, but a is just 1, so we're just going to have this over 2. And when we reduce this, I think what I'll do is just bring a 1/2 out front, and so I can write this as 1/2 times 1 plus or minus square root, and then when you simplify all this, it's just going to boil down to 1 plus 4x. But the thing to notice about y is coming back here, y has to be positive because everything's inside of a square root. But right here, you notice a possible problem. If we have an x, you can just plug something in, like plug in x equal to 5. Well, then this whole expression, this whole thing really becomes negative. Our y becomes negative. That's not going to work. So what we can do is just remove our plus minus, and we'll just change this to a plus. But now at this point, we can just take our y value, plug it back into the integral, and go ahead and integrate this thing. Okay, so now on the rewrite, what I did here is I took this 1/2 right here and brought it out front of the integral just because it's a constant value. Then everything here, we can integrate 1. Here, just to clean this up so we can use power rule on it, let's change this. Let's just rewrite this. Let's just rewrite this as all to the 1/2. Now, technically, if you wanted to be clear about it, you could do a u substitution on this. But I think what we'll do is we'll just do that in our head, just knowing we need to bring a 4 out in the denominator. So going ahead with this and integrating, we've got our 1/2 out front. Integrating 1 is going to give me x. Then integrating here, first with power rule, we're going to have 1 plus 4x. Adding 1 in the exponent, we get 3/2. Then we're going to need to multiply the reciprocal out front, which is going to be 2/3. And then for this 4 right here, I'll just divide off a 4, and we're going to need a plus c. But I think I will just clean this up a little bit. Let's multiply in the 1/2. We could probably leave it, but let's multiply it in and simplify this. So first we're going to have 1/2 x. Then we multiply 1/2 times 2/3. That's going to give me 1/3 divided by 4. It's going to give me 1 over 12, 1 plus 4x to the 3/2, add a plus c, and that's it. Okay, there you have it, UNSW 2024. Thanks everyone for watching. Have a good day.